Pharmacology about neurotransmission and central nervous system. So I here divided the central nervous system. So already you know that central nervous system is of two types. So number one is nervous system is of two types. Number one is central nervous system and is peripheral nervous system. So about this one I will discuss in detail because pharmacology about this one we are going to discuss. So here another is the peripheral nervous system PNS. So PNS in PNS again two types, that is autonomic nervous system ANS and somatic nervous system SNS. So this one and this one I won't teach here. Okay. So now I am moving towards central nervous system. So pharmacology of central nervous system and its neurohumoral transmissions. So what are the neurotransmitters are there in central nervous system and what are the functions of those neurotransmitters? What is neurohumoral neurotransmissions? So neurohumoral means, actually humoral means hormone or chemical agent. Humoral, this means hormone or chemical agent. Hormone or chemical. So neurohumoral means a nerve cell, what are the chemicals or transmitters are there. Okay. So now I am going in detail about this one. So these are the neurotransmitters in CNS. So neurotransmitters in CNS, number one is inhibitory neurotransmitters. Inhibitory neurotransmitters. So in that inhibitory neurotransmitters, GABA, then glycine, then dopamine. So these three are main important neurotransmitters inhibitory. Means these neurotransmitters are having inhibitory action or stopping the neurotransmission in the brain. Okay, so these neurotransmitters are mainly present in brain. Okay, and second one is excitatory neurotransmitters. So in that glutamate and aspartate is purely excitatory neurotransmitters. So you may have question in your mind that then what about acetylcholine? What about acetylcholine? That is also excitatory neurotransmitter, but sometimes it may affect as inhibitory action. So that's why I didn't keep here acetylcholine as purely excitatory neurotransmitter. So neuro means nerve, transmission means some signal. Okay, conduction of some signal or transferring of some signal. Okay, so in inhibitory neurotransmitter, what does it do? These neurotransmitters doing inhibitory action or effect on the CNS. On the CNS. That's why I kept CNS minus charge. So these excitatory neurotransmitters affecting on CNS stimulatory effect. Stimulatory effect. That's why I put it here plus sign. Okay. Now acetylcholine, noradrenaline and serotonin. 5-HT means 5-hydroxytryptamine. So this is the chemical formula of serotonin. Another name of serotonin. So acetylcholine, ACH in short, noradrenaline, NA and serotonin. So these are having both action, excitatory as well as inhibitory action. So mediate both inhibitory as well as excitatory action. So both these three neurotransmitters in CNS having inhibitory as well as excitatory effects. Excitatory effects. Now, what is inhibitory postsynaptic potential? So in short, you can say it as IPSP, inhibitory postsynaptic potential. So I will give detail about this one. What is this? Okay, and how it is doing its mechanism, how it is working. So I will tell after completion of this total presentation. Okay. So what is inhibitory postsynaptic? Inhibitory postsynaptic potential, when an inhibitory transmitters binds, when an inhibitory transmitters like GABA, glycine, dopamine. So any one of neurotransmitter, okay. So when binds where in postsynaptic nerve, where in postsynaptic nerve, and interacts with specific receptors, and in postsynaptic nerve interacts with specific receptors, means postsynaptic having specific receptors according to the neurotransmitters. Okay, so receptors are nothing but one type of protein. Receptors are nothing but one type of protein which is the binding site of neurotransmitter or any chemical or drug. Okay, so agonist drug means like this type of any drug is there, then it can bind with that receptors also. On post-junctional membrane, on post-junctional means in postsynaptic nerve, the membrane is there, in that membrane receptor is present. So in that membrane receptor is present, so there it is binding. And permeability to potassium plus potassium ion, permeability of the potassium ion or chloride ion increases. So actually what is happening in excitatory neurotransmission? There potassium ion coming out in excitatory phase, potassium ion coming out or chloride ion coming out and sodium ion is coming inside. But here opposite action is going on, means potassium is getting inside and or chloride is getting inside. Okay, so here representation inhibitory. Okay, so inhibitory representation in figure, inhibitory neurotransmitter. So sodium is not getting inside and potassium is coming out, and chloride is getting inside. Potassium is coming out and chloride is getting inside. So IPSP is produced. Then in effector organ or cell, hyperpolarization. Hyperpolarization means this is inhibition action. Inhibition action potential. Action potential. AP means action potential. Means whatever the action potential is produced, it is not going to transfer from the presynaptic nerve to postsynaptic nerve. Okay. Then what is excitatory postsynaptic potential? So when an excitatory neurotransmitters, again these are the excitatory neurotransmitters or among these also. Okay, so excitatory postsynaptic potential is nothing but when excitatory neurotransmitters binds and interacts with the specific receptors on the post-junctional, here. Okay, post-junctional membrane. The membrane permeability to cations increases. The membrane permeability to cations. Here chloride was permeable, here sodium is permeable. So potassium is getting outside and sodium is getting inside. So excitatory effect. So on effector cell or organ, depolarization is occurring. This is mechanism actually. So I will tell this one later. So this is the about in brief about inhibitory neurotransmitter and about excitatory neurotransmitter. Okay, so now I will tell what are the effects on being these things. So if hyperpolarization is occurring, means inhibitory action is occurring, then these are the effects. Manifestation means these are the effects of CNS depression. So if inhibitory action or hyperpolarization is occurring, then inhibitory actions will be occur, and by that way these effects we can see on the human being. So drowsiness means in short you can say laziness. Drowsiness means laziness or getting more excessive sleep. Okay, so all time you are feeling dull, so that is called drowsiness. Then sedation, again this is more or less again calmness. Okay, getting calm. Depressed, you are getting depression means you are getting calm. Okay, there is no anxiety. Then hypnosis. Okay, you are just for certain thing you can only concentrate. not for all the things at a time. So hypnosis happened. Okay, so more concentration on a particular thing, so that's why you are getting depression. Okay, then disorientation means not a particular goal you are having, so disoriented from the goal, and confusion. Then unconsciousness, then coma means long term unconscious is nothing but coma. You don't have any feelings or any thinking, but your nervous system is little bit working and there is no proper body functions. So then after long exposure of coma means long term of lack of all the communications from the nervous system and your muscles, all those things if seized, then going to die means breathing also at last will be disturbed. Okay, then effect of depolarization means excitement. What will happen? Excitement, first effect is, then euphoria means feeling extreme happiness, then insomnia means lack of sleep, you are not getting proper sleep, insomnia. Then tremors, you are getting some tremors means regular shaking of particular part of your arm or leg or any part. Okay, tremors. Then twitchings, twitching means stiffness of a certain part. Then convulsions, here rhythmically some shaking are coming regularly, rhythmically, but more than normal. Okay, then again coma, then death. So both are having in excessive manner coma and death. So these are the effects. So now I will tell about your mechanism of inhibitory mainly. So this is very important, please listen carefully little bit. So hope so you are enjoying the video, be concentrated. So now I will tell the mechanism. So glycine is a neurotransmitter and GABA is a neurotransmitter for inhibitory action. So glycine is having CMAD IPS. So this is the effect. What is this effect? In short, I have written here. So glycine will cause these effects on CNS. Number one is cognition, means inhibition of cognition, means you are losing the memory. Then here again cognition, memory and appetite, then digestion, then immune response. So this is very important thing, immune response. So you are getting less immune response. Okay, then this one sleep. Okay, so and this is perception, lack of perception means no proper understanding. Okay, so inhibition action. And this is reducing anxiety, like diazepam is one type of drug, diazepam, which reduces anxiety by doing work on GABA. So how it is working? Now I will show you. So here this is the presynaptic nerve, and this is postsynaptic nerve. Okay, so what is this actually? You may have question. What is this? In postsynaptic nerve, this is actually dendrite or axon, but mostly dendrite. So what is dendrite? You know, all of you know. So this nerve cell is there. So if I am drawing roughly, so like this, and just I am drawing roughly. Okay, so don't be confused. This is cell body. So this is axon, and here nerve terminals are there. So in nerve terminals, buttons are there. Means some here these are the nerve terminal. So one of this button means one of this nerve terminal is this one. Okay. So in nerve, this is one of the nerve terminal. Okay, with electronic microscope. Image is drawn like this. Okay. Then here another one will happen, here another one, like that. So many nerve terminals are there and buttons are there. Okay, and this is cell body, this is dendrite. So this is coming from CNS, this is coming from CNS, and this is towards the effector organ. So if this is first nerve, then this is second nerve. Okay, this is second nerve, and this is presynaptic nerve. Okay, and this is postsynaptic nerve. So both I am putting in PS like that. Okay, so this is presynaptic, this is postsynaptic nerve. So this one I told you. Okay, so here vesicles are present. What vesicles? So these are the vesicles which contain neurotransmitters. So according to the type or neurotransmitters we need, so according to that one, if it is GABA, then GABA neurotransmitters are closed in a vesicles. Okay, so many vesicles are there. Okay, so many vesicles are there. So here now these vesicles will be come out from this like this. Okay, come out, and this is the synaptic cleft. Okay, so this is very little gap, around 0.02 micron. Very little gap, this one, synaptic cleft. So between that cleft junction between two nerve, that is called synaptic cleft. So here releasing these vesicles, actually rupturing the vesicles. Why? By the help of calcium ion. This is the mechanism. This one helping by coming inside or having inside of the exoplasm. This is the axonal end terminal. Okay, so calcium is coming and binding with the vesicles as well as here also, and it is rupturing or fusing the vesicles to the end of the membrane of that node or that button. Okay, nerve terminal. Then here releasing neurotransmitters, and here in postsynaptic nerve there are so many receptors are present. Okay, protein bodies are present. So according to the neurotransmitter, like that receptors only present there, because they can recognize that yes, in that receptor I have to go and bind. Okay, so coming and binding. So don't think that only one neurotransmitter may come here and binding. So many neurotransmitters are coming and binding, and sometimes researchers are telling that even multiple types of neurotransmitters can also come out and binding. So when it is opening, so here this is actually, these receptors actually channel gated. Okay, sodium channel gated. So I have written channel gated. So this is two types of receptors. Okay, so one is sodium channel and another one is potassium channel. Okay, sodium channel and potassium channel. Here also sodium gated channel is there. Here also entry of sodium will occur. So that's why here generation of action potential will happen. Okay, so now sodium channel is open because from here action potential is induced. How action potential is inducing, I will tell. Okay, action potential is induced. So here after action potential induction, okay, so how it is happening, I'll tell just now. First I have to tell you in brief. So here after opening the sodium channel, these neurotransmitters are coming inside. Means it is having some power of transmissions. It is transferring the signal from the CNS to peripheral system. Okay, so transferring the signal. Okay, now getting signal towards the effector organ. Okay, now how action potential is inducing, I'll tell now. Suppose this one I am manifesting or magnifying this one. So suppose this is on channel, sodium channel, this is cell membrane of neuron, cell membrane of neuron, and this is sodium channel, sodium gated ion channel, and this is another one is the potassium gated ion channel. Okay, so actually potassium are inside the cell and having the negative charge inside of the cell in resting stage. If it is in resting stage, so here minus charges are there and potassium is inside the cell membrane. Okay, so here minus negative charge, minus 70 millivolt charge will be there, 70 millivolt. So in resting stage or resting phase, minus 70 millivolt is there inside the cell membrane. So there is no action potential is produced till now in resting stage. Then what will happen whenever some neurotransmitters are coming, neurotransmitters like GABA or glycine or dopamine, whatever, okay, neurotransmitters are coming and binding with the sodium channel. So here after getting this, so this is actually, you can say that these are the powers, having powers to open the sodium channel. So these neurotransmitters are having actually power cell. Okay, these are power cells, you can imagine like that. So these are the power cell. So these are coming and contacting with the sodium channel. So it is opening the sodium or opening the sodium channel and getting sodium inside So here it was previously plus charges. Here previously plus charges, but after getting inside sodium from outside to inside, so here from resting stage to, through graph I am showing you. So in resting stage, suppose this is threshold point. Threshold means the minimum energy which is needed to explore or needed to start the action potential. So this is threshold point. So from here graph I am drawing. So suppose this is the point where threshold means, already I told that generation of minimum energy to do action potential. Okay, action potential, what is that? That is nothing but transferring of signal from one part of the nerve cell to another part or from the axon towards the another cell body of the nerve. Okay, and towards the effective organ. Okay, so here after threshold, so threshold is minimum. This one at resting stage it is having minus 70 millivolt as I told you here. So after getting potential, so it may come to 56 millivolt, minus 56 millivolt. So this is the minimum energy to involve in action potential. So this is the starting point. So after here it will goes to plus 30 to 40, plus 30 or 40 millivolt, means negative to positive it is coming. So it is the stage is called as, this is the stage is called as depolarization. Depolarization means now action potential is started. Depolarization through neurotransmitters action. Okay, now after a certain time it will again reduced. So depolarization is going to reduce. Then up to here it is coming hyperpolarization, means below this threshold, below the threshold hyperpolarization means again less than this one, below threshold it is coming hyperpolarization. Hyperpolarization means inhibition of the action potential. Inhibition of the action potentials. What will happen here? How it will occur? Then after a certain point, when concentration is fulfilled, means saturation is occurred, then again this one will be closed and potassium will be go out. So hyperpolarization means more negative than this previous resting stage. Okay, so before hyperpolarization, in between depolarization and hyperpolarization, there is a stage called as repolarization. What does it mean? Means again another signal will come from that point. So how signal actually occurring? So from this is nerve. 1 minute. This is the nerve cell. So in this position, suppose between axon and cell body of the nerve, here started one action potential. So it is coming some other place, then started depolarization, then depolarization, then hyperpolarization, then again another signal should come, means another transmitters is coming and binding, then again another will be started. So like that depolarization will occur. Okay, so here again same cycle will go on continue and transferring of the signal occur. So this is all about neurotransmission and central nervous system of pharmacology, and what are the manifestations of CNS depression and stimulation, means what will happen after binding the GABA to the receptor and after binding the other neurotransmitters to the post-synaptic nerve, or are the effects already I discussed. So hope so that you enjoyed this video, and if you understood, so please like it and share it and subscribe, and please share to your friends as well. Thank you for watching. Next again very soon I am coming online.